Alright, so in this video I'm going to be explaining this important paper with the title Neural Graph Generation from Graph Statistics. This NeurIPS paper in 2023. We describe a new setting for learning a deep graph generative model from aggregate graph statistics rather than from the graph adjacency matrix. Matching the statistics of observed training graphs is the main approach for learning traditional GGMs. Privacy researchers have proposed learning from graph statistics as a way to protect privacy. So we develop an architecture for training a deep GGM to match statistics while preserving local differential privacy guarantees. Our main motivation for generating graphs from statistics is privacy preservation. There is a direct tension between releasing real graphs to the research community and privacy concerns of the individual entities. This is a figure for generating realistic looking graphs with local differential privacy. So here we have aggregated graph statistics, and based on degree histogram, triangle histogram, we have statistics based GGM, so we generate synthetic graphs based on degree histogram. So there are some contributions in this paper. They introduced GenSat, the novel deep graph generative architecture that requires access only to graph-level statistics. They show that given training statistics collected with the local differential privacy guarantee, GenStat also satisfies local differential privacy while generating high-quality graphs. We identify permutation invariant differentiable graph statistics that are based on aggregating node-level information and support realistic graph generation across multiple diverse domains. So GenSat assumes that a training graph is summarized by a set of observed M graph statistics. So given a distribution over adjacency matrices, we let I denote the random variable denoted by applying the descriptor functions to a random graph A. So we define the mixture model. Now Z here is a graph latent representation with associated prior P of Z. The marginal distribution over graph statistics, this is the marginal distribution. And we assume graph statistics are independent given the probabilistic matrix A tilde. And model the conditional distribution of each graph statistics as a Gaussian with diagonal variance parameter. Given the conditional distribution equation, the marginal distribution equation is a mixture of Gaussians. This is the proposed latent variable model. The diagram shows the dependency of graph statistics on the latent probabilistic adjacency and graph-level latent representation Z. So they define the following permutation invariant inference distribution. P theta over statistics, and C here is the number of graphs that generates the same statistics. So this is the visualization of generated graphs by the statistics-based GGMs.